Assalamualaikum and a very good day to everyone. I am Alisa Razidi. Today, our group will be presenting the topic Techniques of Differentiation, which is a fundamental concept in calculus. Before we begin, let us briefly explain what differentiation is. Differentiation is a mathematical process that is used to determine the rate of change of a function, or in simple terms, how one quantity changes in relation to another. It helps us find the slope of a curve, the velocity of a moving object, and many real-life applications in science, engineering, and economics. There are several important techniques that makes differentiation easier and more systematic. These include the power rule, product rule, quotient rule, chain rule, and also methods such as implicit differentiation. Each technique allows us to differentiate more complex functions efficiently. In this presentation, we will introduce the topic, explain the problem statement, and demonstrate the step-by-step solution using the appropriate differentiation technique. Our goal is to help you understand not just the final answer, but also the reasoning behind each step. Now, let's begin our presentation on techniques of differentiation with our first presenter, Anis Nazura.
Hello everyone, so today our group will present about techniques of differentiation. Oh wait, before that, we need to note about what is differentiation. Differentiation is a process in calculus used to find the rate of change of a function. The result of the differentiation is called the derivative. So this is a few techniques of differentiation in calculus. We have power rule, constant multiple rule, sum and difference rules, product rules, quotient rule, chain rule, and implicit differentiation. So each of them I put a formula to.
For question 2, we will work through two derivative problems step by step. First, we will use the product rule on y equals to 9 exponential of x times with tangent in bracket x minus 3. Then, we will use the quotient rule on y equals to x squared plus 1 divided by sin x. I will state the u and v, compute the derivatives, apply the rule, and simplify. Follow the algebra with me. I will point to each step as we go. For the first function, y equals to 9 exponential of x times with tangent in bracket of x minus 3, I label u equals to 9 exponential of x and v equals to tangent in bracket of x minus 3. Their derivatives are u prime equals to 9 exponential of x, and for v, we use the chain rule, which is differentiate the outer part of the bracket first, then differentiate the inner part of the bracket. Then it will equals to v prime equals to secant square in bracket of x minus 3 times with 1. Then simplify the derivative into v prime equals to secant square in bracket x minus 3. Then, I apply the product rule with the formula y prime equals to vu prime plus uv prime. Substitute all the parts and factor out 9 exponential of x to get the final answer. The final answer is y prime equals to 9 exponential of x in bracket tangent in bracket of x minus 3 plus with secant square in bracket of x minus 3. For the second function, y equals to x squared plus 1 divided by sin x, I set the numerator u equals to x squared plus 1 and the denominator v equals to sin x. Their derivative are u prime equals to 2x and v prime equals to cos x. Using the quotient rule with the formula y prime equals to vu prime minus with uv prime divided by v squared, substitute everything in and simplify the numerator to obtain the final expression. The final answer is y prime equals to in bracket 2x sin x minus with in bracket x squared plus 1 times with cos x divided by sin square x. That's the end of the second question. Next, we will go to the third presenter, Nur Amna Hanani.
Hi guys, so I am Amna. So I'll be the one who explain question 3 for you guys. So let's read the question first. Given ln y plus sine to the power of 2 in bracket x squared plus exponent to the power of y equal to 5xy. Find dy dx using implicit differentiation. So do you think how we have to solve this question? Let's go. So are you ready? Let's start. So first we have to divide this equation to 3 parts. We have part A is equal to ln y, part B is equal to sine squared in bracket x squared plus exponent to the power of y, and part C, 5xy. So each part we will differentiate to its first derivative. So let's start with part A. Part A is equal to ln y. If we differentiate ln y, we will get 1 over y. And we have to multiply it with y prime, that's equal to dy over dx. For part B, we have to use chain rule. So first, we will differentiate the sine square, the square for sine term. So we will get 2 sine in bracket x squared plus exponent y. Then we'll multiply by differentiate of sine, we will get cos. So we will get cos in bracket x squared plus exponent to the power of y. Then we'll differentiate in the bracket of the original term. So we will get 2x plus exponent to the power of y multiplied by y prime. So as you can see, b prime is equal to 2 sine in bracket x squared plus exponent to the power of y multiplied by cos in bracket x squared plus exponent to the power of y and multiplied by 2x plus exponent to the power of y, y prime. So let's move to part C. Part C, we have to use product rule. So product rule The formula for product rule is y prime equal to uv prime plus vu prime. So at the final answer, we will get c prime is equal to 5 multiplied by xy prime plus y. Okay, after we differentiate all the parts, we will combine the first derivative of each part in one complete equation. Before that, we will let m equal to the term x squared plus exponent to the power of y for us to easier to understand and also to write. So the whole equation will be 1 over y times y prime plus 2 sine m cos m times in bracket 2x plus exponent to the power of y prime equal to 5 times in bracket xy prime plus y. So this equation, we will expand the first part A, and also the third part, which is part C. And for part B, we will using double angle formula to simplify the equation. So the double angle formula that we use is sin 2a equal to 2 sin a cos a. So after we simplify and we expand the equation, the first equation, we will get y prime over y plus sin 2m times in bracket 2x plus exponent to the power of y prime equal to 5xy prime plus 5y. Okay, the third equation we'll get after we expand the second part, which is part B. So after we expand the part B, we will get y prime over y plus 2x sine 2m plus x to the exponent to the power of y prime sine 2m equal to 5xy prime plus 5y. Okay, after that, we will rearrange the equation and let all the terms that have y prime in the left side of the equation and all the terms that have no y prime to the right side of the equation. So we will get y prime over y plus exponent to the power of y times y prime sine 2m minus 5xy prime equal to 5y minus 2x sine 2m. From this equation, we can factorize the y prime to simplify the equation. So after we factorize, we will get y prime times in bracket of 1 over y plus exponent to the power of y sine 2m minus 5x equal to 5y minus 2x sine 2m. After that, we can make y prime a subject formula. So the answer will be y prime equal to 5y minus 2x sine 2m over 1 over y plus exponent to the power of y sine 2m minus 5x. Alright, the first equation that you can see in this slide is not our final answer since we use m in the equation. So we need to change the m to the original term, which is x squared plus exponent to the power of y, and y prime to dy over dx. So the final answer, we will get dy over dx equal to 5y minus 2x sine 2 times in bracket x squared plus exponent to the power of y divided by 1 over y plus exponent to the power of y sine 2 times in bracket x squared plus exponent to the power of y minus 5x. That is our final answer for this question.
So for the last part, I will explain question 4 for you guys. So for question 4, we need to use linear approximations, and that is a formula that we need to use. The formula is f x naught plus delta x equal to f bracket x naught plus f prime bracket x naught delta x. Now, I will explain how we use linear approximation to estimate the value of the function at x equal to 8.02. From the expression, we need to replace to fx, and we get x squared minus x the power of 1 over 3. So, our target value is x equal to 8.02 because linear approximation works best near a simple number. So, we choose in x naught equal to 8. Next, we calculate the small change in x, which we call delta x. From the slide, we know that delta x equal to 0.02. Then, we differentiate the function. The derivative of x squared is 2x, and then the derivative of x the power of 1 over 3 is 1 over 3, x the power of minus 2 over 3. And we get fx equal to 2x minus 1 over 3x squared, 3x, 3x the power of 2 over 3. Later, we will substitute x naught equal to 8 and delta x equal to 0.02 into the linear approximation formula to estimate the value of the function at 8.02. This slide shows all the important setup steps. The function, the chosen value, x naught, the change, delta x, and the derivative. Now, I will continue with the linear approximation calculation. We use the formula. In this question, x naught equal to 8 and delta x equal to 0.02. So, we estimate the value of the function at 8.02. First, we calculate the original function value. Since we know 8 squared equal to 64 and the cube root of 8 is 2, we get 62. Next, we calculate the derivative at x naught equal to 8. We already found that fx equal to 2x minus 1 over 3x the power of 2 over 3. Now, after calculate, we got 191 over 12. So after that, we need to substitute everything into the approximation formula. So we get 62 plus 191 over 12 multiplied with 0.02. When we calculate this, the answer is 62.31833. So finally, we round it 2 decimal places and our estimate value is 62.32. Finally, this linear approximation helps us estimate the function easily without using a calculator for the full expression.
So in conclusion, differentiation plays a very important role in calculus because it allows us to understand how quantities change throughout this presentation. We have reviewed several key techniques of differentiation, including the product rule, quotient rule, chain rule, and other related methods. Each technique helps us solve different types of function more efficiently and accurately. So by applying these techniques correctly, we can simplify complex problems and obtain solutions that are essential in mathematics, science, engineering, and real-life application. We have also demonstrated the problem statement and shown the step-by-step solution to illustrate how these techniques are used in practice. Lastly, we hope this presentation has provided a clearer understanding of the topic techniques of differentiation. Thank you for watching and we appreciate your time. Bye guys.